Welcome to Homework Lib.
Alright, so here we are striking a laser beam on a CD, right, on a compact disc. Now the wavelength of light that we are striking is 790 nanometers, right? And the laser beam reads the start and end of the bits by seeing whether the reflected beams of light gets cancelled or not. Okay, now if you look in the figure, so one of the light gets reflected from this surface and the other gets reflected from this surface. Both the surfaces are same, so either both of them will have change of phase or none of them will have. So we have a very simple equation for the condition for interference or for constructive or destructive interference. So since we need destructive interference to cancel out each other, so the path difference between the two reflected lights, path difference should be a multiple of m plus half and wavelength of light, but lambda inside the plastic substrate. So let me write that as, right, substrate, inside the substrate, and the refractive index of the substrate, let me write that as ns, that is equal to 1.8, and the wavelength inside the plastic substrate is given as, the wavelength decreases, so the wavelength in air divided by the refractive index of the plastic substrate, right? Now the path difference between these two reflected beams will be the twice the depth, right? Twice this depth. So what I can write is twice the depth is equal to m plus half. Now lambda s equals to lambda by the refractive index of substrate. So what we need to find is d. So let me write here, I have plenty of space here. So d equals to m plus half lambda by 2ns. Now we want d to be minimum, so we can consider m to be 0. M starts from 0, 1, 2, right? So for minimum of value of d, that is the depth, we can consider m to be 0. So this becomes lambda by 4 times ns. Alright, so what is lambda? 790 nanometers, and 4 times 1.8, so 7.2 is equal to 790 divided by 7.2. Therefore the minimum depth we require is nearly equal to 110, so exactly it's 109.72 nanometers. Alright, so this should be the depth of the bit, and this is the solution for the question.